Hello, everyone, and welcome to today's webinar, Botrytis, Destructive, Persistent, and Preventable, presented by BioWorks. I'm Robin Sittberg of Meister Media Worldwide, and I'll be moderating the webinar today. We'll have some time for questions at the end of the webinar, so if at any time during the presentation you'd like to ask a question, just type it in the question pane at the lower left corner of your screen and click Submit. And you can do this at any time during the webinar, and we'll answer questions at the end. And before we begin, I'd like to introduce today's speaker. Dr. Michael Brownbridge is Senior Technical Services Manager with BioWorks. He provides technical support for the company's catalog of disease and pest management solutions and their application in integrated plant health management programs. Prior to joining BioWorks in 2019, he was fortunate enough to have traveled the world applying his craft with research and outreach positions in Israel, Kenya, the US, New Zealand, and Canada, putting new biological tools and knowledge into the hands of growers. So I'm going to go ahead and turn it over to Michael Brownbridge.
Great stuff. Thank you, Robin. Are we all okay to go? Is everything working from your end?
Yes, we are.
Wonderful.
Take it away.
Thanks a lot. Well, good afternoon, everybody. Thanks for tuning in. The entertainment this afternoon is going to be all about botrytis and ways in which we can manage it. So let's start off just thinking about botrytis and why is it such a problem? In part, it comes down to botrytis' ability to infect and survive on such a wide host range of plant species. And botrytis also tends to infect what I'll call the sellable, or the most important part of the plant, which is typically the fruit or the flower. So it's a really tough one and something we really need to get a handle on. If I look at it in human terms, if you will, botrytis is a rock star in the pathogen world. It can infect over 200 plant species, and that means there's never any shortage of hosts for it to infect and survive on, both indoors and out. So that in turn means that there's no shortage of inoculum sources. So there's always infectious spores around in the environment, and those spores are easily dispersed within a crop. And if you've ever touched botrytis infection in a flower or on some dead plant material, you know how readily those spores just go off in a gray-brown cloud and become airborne. So very easy to disperse. And the spores can also survive for a long time in crop debris, in soil, or in growing media. There's also a declining number of synthetic fungicides for botrytis. Few effective products in organic production systems, and no synthetics that can be used in cannabis. And considering all of these factors, it makes you realize that there really is no quick and easy solution for this pathogen. So hopefully none of you are tuning in and hoping I could give you the silver bullet solution, because not for this one. So for those of you who think, we can still protect plants against botrytis using chemistry. As I mentioned, the list of effective chemicals is shrinking rapidly. And Botrytis cinerea particularly is now resistant to multiple FRAC groups. And this is always something you should consider if considering using chemistry. Don't just look at the name of the product, look at the FRAC group of the product, because name of products can vary, but they can contain the same active in a certain FRAC group. So always look at the FRAC group if you're considering rotating chemical fungicides. But considering the number of FRAC groups to which botrytis is now resistant, it should give paused thought to everybody that we need to consider use of other materials and practices in a resistance management program. And resistance continues to evolve and spread, and that has a real major impact on our capacity to manage this disease, both in indoor and in outdoor crops. And that global exchange of plant material means that spread of resistance is inevitable. And just considering this graph for a couple of minutes, when you look at these sort of what I'll call sort of stalwart fungicides that we've relied upon for a long time to manage botrytis in Luna, Kenja, Switch, Miravis Prime, and that, you look at how resistance was maybe relatively low in 2017, 2018, but then by even 2021 to 2022, a lot of the plants were certainly resistant to Luna, Kenja, and Switch. So it's just a matter of time before Botrytis develops resistance. It's always handy, I think, to know and understand the life cycles and the conditions required for plant infection to occur, because that then helps the development and implementation of cultural and other practices to manage, in this case, Botrytis. And you're probably all familiar with the so-called summer cycle of Botrytis, where the disease initially establishes on compromised, dead, or senescing plant material. It's easy to access, and it gets a toehold in a crop or a cropping area that way before it transitions to what we call a necrotrophic life cycle, or lifestyle, I should say, capable of infecting and killing healthy plant cells. It has a very rapid life cycle and produces millions of infectious spores within a very short amount of time. What you may be less familiar with is the so-called winter cycle, where the fungus can actually produce sclerotia. And a lot of other fungi can do this, but sclerotia are incredibly tough survival structures, and they can live for months in soil or on crop debris. And that means infections can carry over from one season to the next. So let's consider plant infection, and specifically here, infection by Botrytis, and ultimately disease management through the lens of the disease triangle. You've probably seen this a million times if any of you went to college or university and did courses on plant pathology. You know that what the disease triangle does, it just sort of boils down the essential elements for plant infection to occur. And this means there must be inoculum from a virulent pathogen that has to be present at high enough levels to infect a susceptible host plant. And the environmental conditions have to be just right for disease development. And infection will only occur if all three of those elements are satisfied concurrently. And if we can eliminate any one of them, we can significantly reduce the likelihood of disease developing and spreading within a crop. So what does that mean? How do we reduce pathogen levels? One of the ways is by good sanitation practices. So you're going to manage the ingress and availability of infectious material. And the other is through the use of chemical or biological agents. We can also reduce plant susceptibility to specific diseases through use of resistant varieties, genetic resistance or other. And really one of the things we should be doing all the time is increasing the plant's ability to tolerate and recover from abiotic stress events. And the more we can do that, the healthier the plant, the more tolerant it is going to be to disease infection. I'm going to keep banging away at this. You know, we know sanitation is a critical component of any cultural management strategy. And for Botrytis, as I sort of already alluded to, we know that the spores can be readily carried from location to location by wind currents, on clothing. And as Botrytis cinerea certainly can infect over 200 plant species, it's highly likely that there are sources of inoculum in adjacent habitat or crops. And how can we limit their ingress? If we can figure that out, that's a great first start. But we know, of course, that Botrytis spores and sclerotia can survive in soil and in other crop debris. And that makes sanitation practices even more important, as you want to remove all potential sources of inoculum from one crop to the next. I would say basic sanitation practices are fundamental. And with this foundation, we can then set the stage for successful use of early intervention and prevention strategies. Oops. And we can't ignore the impact of stress on plants and the effect of stress on their susceptibility to infection. Stress in humans, we know, is a weird and wonderful thing, and can have a lot of very strange and wonderful and terrible side effects. But one of the side effects is when you're stressed out. Typically, that's the time when we'll come down with flu or with a cold, particularly because we're stressed, and it means we're spending more energy and resources taking care of ourselves rather than sort of, say, fighting off infections. But as humans, we have the capacity to take steps to reduce stress and to move away from stress-causing situations. But plants, alas, can't take time off to relax. They can't pull up their roots and move out of a place that's cold and wet to one that's warm and dry, or conversely, move out of a place that's just way too sunny and hot and move to a place in the shade. They're static. They stay where they are, and they're reliant upon you supplying most of the primary inputs and doing whatever's possible to reduce or eliminate stress to keep them healthy and productive. And then plants are challenged by a range of abiotic stress factors, such as extremes of temperature, low water availability, or the flip side of that is excess water, such as the plant might be exposed to through overwatering. Nutrient deficiencies or nutrient excess, pH, salinity caused by excessive use of salt-based fertilizers, things like that. And there's a host of other factors that can just stress plants out. And while some of these effects and events may be transient and plants can recover just fine, others can have a lasting effect on plant performance, and it leads to poor plant performance and poor fruit quality or plant quality. Abiotic stress, we know, I'm sure you all seen this, abiotic stress can also render plants more prone to biotic factors. What do I mean by that? Basically, diseases like botrytis and pest attacks, which further affect plant performance and quality. So let's take a look at some of the factors involved in creating a favorable environment for a plant. Creating a growing environment that is unfavorable for the pathogen and doesn't cause plant stress, we also help limit infection. So a key requirement for botrytis infection is that ambient humidity has to exceed 85%. So if you can take ambient humidity and reduce RH to 65% or lower, I know that's not always possible, but there's other things that you can do as well by improving air movement through a growing area, for example. That helps dry up free moisture on leaves or buds and eliminates microclimates where relative humidity can be high. And that can be done mechanically, and you can help air movement too by pruning leaves. But of course, that's always a balancing act. You don't want to remove too many, you don't want to remove too few. So getting that right, it means understanding the crop. Creating a canopy ultimately that's less dense improves air circulation. And in crops like cannabis, one of the things I've seen done is actually growing fewer plants per unit area. Now, you could say we've got to cram plants in there to get maximum production, but what typically happens is that those fewer plants tend to be healthier and more productive. So there's less spent on crop inputs, on managing diseases, and typically each of those plants is more productive. So food for thought. Installation of dehumidifiers can be essential in some parts of the world, and if possible, again, use temperature to your advantage and keep temperatures out of that optimal range for botrytis. And if you think about it, when we see botrytis most, and it relates to these two factors, are in the sort of overcast, cooler times of the year, which have a higher humidity, or the greenhouse just doesn't dry out as fast. And those are the times in late winter and spring when we're trying to grow crops without that light and warmth that botrytis can just run rampant. So various plant management strategies as well can be advantageous. Good irrigation practices, they are essential really to general plant health and well-being. Again, finding that sort of Goldilocks spot is to keep the plant happy, well-watered, etc., but not overwatered. That's the key. And what is enough water? That's going to be influenced by the growing medium used and by the time of year. A lot of factors to weigh into when is that plant got enough water. It's important too, I think, to try and minimize overhead irrigation. or watering late in the day, and that's important to allow plants time to dry out in between irrigation events. It's a similar concept really for plant nutrition. I know many times plants are pushed with high nitrogen inputs, but that can be a recipe for disaster, as rapidly expanding plant tissues are often softer and more prone to infection, particularly by pathogens like Botrytis. Also, that softer tissue tends to lead to more pest issues at the same time. And additional nitrogen in there, that's just like good food for insect reproduction, and that those amino acids and everything in the plant just help insects produce more eggs. So infestations can just build like crazy. But it's not only macronutrients that are important, it's also many micronutrients are essential to plant cell development and plant development. So in an ideal world, also, infected plant parts or infected plants should be removed, because you're removing that source of inoculum for the rest of the crop. But I understand that in many cases that may not be practical on a large scale, but it is good practice. So talking about essential macronutrients, well, calcium is an essential element for healthy cell development. But it's one of those elements that doesn't translocate easily within the plant, especially to leaf and petal margins. And that's why we sometimes see deficiencies that manifest in the form of sort of tip burn in various crops. Imagine what we've got when we've got tip burn. It's basically necrotic tissue. Oh, if I'm Botrytis, this is what I'm looking for. It's an ideal point of infection for such a pathogen. And that's why many crops where calcium sprays are used to elevate calcium levels in these hard-to-reach plant parts. And we know the importance of calcium. It's important to cell structure, the bonds between cells, and cell wall strength. And higher calcium levels in the plant typically allow those stronger bonds to be formed before cells and stronger cell walls to develop. And that in turn enhances resistance to enzymes produced by Botrytis during infection. So stronger cells, stronger cell walls means reduced susceptibility. So again, here's another tool we can use to reduce plant susceptibility. And this was actually borne out in trials done at Clemson University by Dr. Jim Faust, working in Petunia, where flowering plants, these flowering plants were inoculated with Botrytis and infection monitored under different treatment regimes. And perhaps surprisingly, perhaps not, disease severity was actually lowest in plants that were sprayed with product On Guard Calcium. Now, On Guard is a protein hydrolysate product that can improve movement, or the efficiency of movement of calcium into the plant, where it can be immediately made available for use in cell production. And in turn, that renders the plants less susceptible to Botrytis infection. And while we generally look for deficiency symptoms in leaves, nutrient deficiencies clearly impact root development as well. So you could say, gosh, why are you talking about root development when we're talking about a foliar disease? Well, roots are kind of important to plants. So it comes down to growing plants which are more resilient. So plants with healthy roots are typically plants which have healthy above ground parts as well, and to achieving a resilient crop. And again, a resilient crop is inherently less susceptible to disease. Now, plant resistance to disease can be a game-changing factor in any disease management program, and same is true for Botrytis. And various studies have shown that there is variation in cultivar susceptibility to Botrytis. And this particular study was carried out using mutants of Arabidopsis. For those of you who know Arabidopsis, it's typically used in plant studies. It's kind of like the plant equivalent of the lab rat in plant genetic studies. The authors of this study found that several factors rendered the plants more or less susceptible to Botrytis infection. And looking at it, they monitored the different genes that were expressed when plants were challenged with botrytis, and those that showed resistance showed that various plant defense genes were induced in those resistant mutants, ranging from those controlling cell wall function to production of cuticular waxes. All of those means that they're creating a stronger plant, if you will, one that's harder to invade by a pathogen such as botrytis. It's much more difficult for that pathogen then to penetrate the leaf cuticle, which is the sort of the primary protective layer around the leaves, and gain access to inner leaf tissue. So genetic resistance certainly has been demonstrated in a model plant. But what about crop plants? Yeah, same is true. We can also see that there's variation in susceptibility of different cultivars of crop plants. In this example, we're seeing significant differences in the resistance or susceptibility of strawberry flowers. And the underlying mechanisms, again, were genetically regulated. So that led to a sort of a complex and multifaceted defense response in the resistant cultivar that wasn't evident in the susceptible cultivar, i.e. the genes that were expressed in the resistant cultivar weren't expressed in the susceptible cultivar. So again, resistance exists in crops of economic importance. And what about cannabis? I don't think there are any breeding programs yet breeding for resistance to botrytis. Variety selection is typically, I would think, and probably more market-driven than IPM-driven. But there's evidence to suggest that botrytis incidence is actually lower in varieties which have what I'll call looser or more open plant and flower architecture, as the structure allows the leaves and the flowers to dry more quickly. Sativa versus indica. I guess this is an age-old conversation in the cannabis world, but some claim sativas are superior to indica because of their open architecture. And there are certainly some commercially viable sativas where botrytis incidence has been notably lower than in comparable sort of indicas. It's important to take a holistic view of plant health management, and we're not just looking solely at managing a disease. We're managing the plant so we can create the best plant possible. As part of that management strategy, we also have to be aware that we need to manage pests as well. And pests like fungus gnats can actually passively vector botrytis spores around the greenhouse as adults. They don't pick them up intentionally. It's just as they move over leaves or in spaces where botrytis spores are present, they pick them up on their hairy bodies, and then as they flip from one plant to the next, they can deposit botrytis spores. So important to control adults, but I would say important to control fungus gnats, period. Not solely because of the vectoring ability, but larval feeding on plant roots can create damage on those roots, and that's a point of entry for other diseases, soil-borne diseases specifically. So proactive management of pests like fungus gnats is another piece of that disease management puzzle. And these pests can be managed by good cultural practices, by not overwatering crops so the upper layers of the media dry out, because fungus gnats only live in that sort of top inch or so of media, so if it's dry, they just don't like it. Use of nematodes like Steinonema feltii and soil-dwelling predators like Stratiolaelaps and Atheta. So we can build a strong foundation for botrytis management through the implementation of good sanitation and cultural practices. And well, let me back up a minute. So collectively, all of those actions that we take, the good cultural, good environmental, good sanitation practices, help to reduce disease incidence, and they help grow stronger, more resilient again, and more productive, I would say, plants. And all of those aspects together help us shift the dynamics of the disease triangle in our favor and creates conditions where management tools at our disposal will work more effectively. Biopesticides, for example, further complement disease prevention activities. And biopesticides are classified by the EPA as products derived from natural sources. And then they're further subdivided into two categories, into biochemical or microbial pesticides. One biochemical biofungicide that you may not think about first as a go-to for botrytis control is actually potassium bicarbonate. And products like Millstop and Caligreen are usually thought of as solutions for management of powdery mildew. They can also be extremely useful as suppressive agents for botrytis. Being a salt, potassium bicarbonate's the primary active here. That physical mode of action is really what I'll say is agnostic in terms of its effects on a range of fungal pathogens. And it can provide control on contact by desiccating fungal spores and actively growing fungal mycelia. So again, it's inexpensive and it's a useful tool to perhaps work into a resistance management program. There are various plant defense activators on the market too, like regalia, that stimulate the plant's production and accumulation of proteins and other compounds that are important in plant resistance, innate plant resistance. These are compounds that have antifungal properties and then enhance a plant's own defense capabilities. And they can improve resistance to several diseases, including botrytis. So again, these are excellent additions to a program. If you think about it, using a plant elicitor or an activator helps the plant work from the inside. And then if we can combine that with a contact fungicide like Millstop, you've got efficacy from the outside and from the inside. So again, these are combinations to think about, different points at which we can attack this disease. EcoSwing, it's another plant-derived product, sort of a hybrid in some sense, in that it has some contact activity that can disrupt fungal cell walls, but it also appears to invoke innate plant defense mechanisms that can also inhibit fungal infection. So let's move on to some of the microbials, where the primary mode of action to some of the bacterial biofungicides based on Bacillus and Streptomyces is antagonism. And this is due to antimicrobial metabolites, lipopeptides, that these bacteria produce during fermentation. And when they're produced commercially, they're fermented in giant fermenters, fermenting vats, and the media used to produce the bacteria are optimized so that they will pump out a lot of these lipopeptides. And these are contained in the formulated products. So applications of products based on Bacillus, based on Streptomyces, can have an immediate antifungal effect. When talking cannabis, we often err on the side of caution around the use of microbials in late flowering, and generally recommend cessation of use of microbial products around 3 weeks prior to harvest, although they can be extremely effective in controlling botrytis in flowers. And the data in the graph are from lab trials conducted by Dr. Zamir Punja at Simon Fraser University, who ran these assays on excised flowers. And they show how well a product like a Bacillus-based product, Stargus, can prevent infection by the pathogen. And Asperello similarly prevented infection by botrytis in this trial. Now, Asperello is based on Trichoderma asperellum, of course. And along with other trichoderma-based products like Root Shield Plus, are better known as biofungicides for soil-borne diseases. But these trichoderma species are actually also very effective against foliar and flower pathogens. And they typically work by colonizing plant surfaces, by competing with botrytis for space and resources, as well as through the production of antimicrobial compounds when they're actively growing. Unfortunately, application by spraying is not on all labels, but one thing we actually have in Canada, which is not on any of our US labels, it's for Root Shield HC, we do have spraying on the label. And these data are from a greenhouse trial carried out in a commercial cannabis growing facility in British Columbia, where weekly treatments with Root Shield HC that one there, provided the best levels of protection and reduction in botrytis-infected flowers, followed by regalia and double nickel. And a little sort of sidebar from this study showed that, yes, when applying products containing spores, you are putting spores onto the plant, but the net result was actually that plant, when it was sent for total mold and yeast counts, had fewer CFUs isolated from the flowers. Why is that? Number one, these products reduced botrytis, so there's millions of spores taken out of the equation. They also reduced incidence of what I'll call spoilage fungi like aspergillus and penicillium. So they suppressed growth of several species of fungi, suppressing growth, suppressing spore production. So there was a net decrease in spore levels on these flowers by using these spore-containing products. Just a little aside, I thought extremely interesting. So here we are. You're not going backwards, don't worry. You've seen this graph before. But I wanted to highlight really how different treatments affected botrytis infection in petunia flowers. And this time, we're going to take a closer look at root shield in this case, Trichoderma hartzianum, which was applied by drenching. Infection levels were lower than in the untreated botrytis check plant, which says that something's going on here. That treatment decreased infection. If you cast your mind back to an earlier slide which said how trichoderma can protect plants, one of the ways in which they protect plants is through activation of the plant's defense mechanisms, the plant's own innate defense system. And I suspect that's the effect that we're seeing manifested in these results. As we like to say, and now for something completely different, another fungal biofungicide, Botrytis, and it contains spores of Ulocladium udimanzii. This is a really quite a unique biocontrol agent. And when applied, in the classic sense, it doesn't actually control a pathogen, but it prevents the pathogen. And it does this by rapidly colonizing dead and senescing plant tissue. Of course, these are sites that botrytis will initially colonize. So by outcompeting botrytis for the space and resources at these sites, it prevents the disease from establishing. And by the way, it only affects dead tissue. It's non-invasive. It doesn't infect living plant tissue. So very safe. And the mode of action means it's highly unlikely you'll get any resistance to this product. And these are some results where Botrytis was included in an organic program in wine grapes in California, where botrytis incidence and severity, was significantly lower in the program where Botrytis was included than in the standard program that was in place in the vineyard. So great product to use both indoors and out. Some more data here. This time in outdoor grown raspberries, where Botrytis significantly reduced the incidence and severity of the disease. The 3 and 4 pounds per acre rates provided levels of control that were as good as those provided by Captan, and significantly enhanced the marketable yield of berries. And last, these are data from trials run in greenhouse cannabis. There's 2 data time points showing infection levels in flowers 21 days after flowering commenced and at harvest. Now, all Botrytis treatments effectively suppress botrytis, with the 4 pound rate providing the best level of protection overall. The great thing about Botrytis is that it's compatible with other biofungicides. Again, I'm thinking Millstop and Regalia, and they can all be used together within a program. Which raises the question, all right, fine, great, biologicals are great, and they are, but what about the compatibility of biofungicides with synthetics? What if you have to use synthetics? What if you're using synthetics? And I include this slide just to show that these are data from strawberry trials, or trials carried out in strawberry fields in Florida, where Botrytis alone at 3 or 4 pounds per acre significantly reduced the incidence of botrytis on berries compared to the untreated control. Botrytis was also tested in a spray rotation where it replaced Captan in a switch Captan rotation. And then the switch Captan is typically a recommended standard treatment in strawberry production, certainly in Florida. And what you see from the data, that there were no yield or quality penalties to using Botrytis in place of Captan in the rotation. And the effectiveness of the program against Neopestalotiopsis was maintained. But again, if you think about it, the number of chemical sprays was reduced. We're introducing some control agent with a totally different mode of action into that program, and that reduces the likelihood of resistance developing. So this type of approach, using chemistry and biology together, gives us huge advantages in terms of our ability to manage resistance. I say that, and I include this slide just as a word of warning. These are data out of the University of Kentucky on the relative efficacy of a range of biological and conventional products for control of angular leaf spot caused by Pseudomonas syringae on tobacco. Turns out that Botrytis is also pretty darn useful in the control of bacterial leaf spots, Pseudomonas and Xanthomonas. And in this trial, it outperformed all other treatments in terms of reducing disease progression and severity. And you see that if you're trying to find it, here's the Botrytis alone. You can see how well it did compared to every single of the other treatments, which included a lot of heavy-hitting chemistries. But when it was combined with Nordox, disease control was worse. Now, Nordox is a copper oxide fungicide, bactericide, and copper products are typically harsh on microbes. So this combination wasn't really a suitable one, but it does serve to highlight the importance of compatibility knowledge before simply tank mixing or rotating biology with chemistry. So a final word really about application practices. What's important to get the best level of coverage and control. A range of spray equipment, we've got access to huge number of sprayers for application of foliar products, including biofungicides. And while each type of sprayer utilizes different methods to produce and deliver those spray droplets onto the plant, in all cases, the goal is to get thorough coverage of foliage and good penetration of the plant canopy, but not to spray plants to runoff. You see a lot of labels with this sort of obscure message saying spray to the point of runoff, but not to runoff. So again, it's understanding your sprayer, how to apply, maybe applying so the leaves are glistening, but you do not want product dripping off those leaves. Generally speaking, fine spray mists provide better coverage and improve efficacy and reduce the likelihood of runoff occurring. And furthermore, those fine spray mists, they will dry faster. So the risks of leaves and flowers remaining wet for extended periods, and you think about it, if you are Botrytis, free moisture and high humidity, that's Botrytis nirvana. So if you leave them wet for extended periods, you're increasing the likelihood of Botrytis infection. If you dry them out faster, likelihoods of infection is significantly reduced. So my word to this, invest in quality spray equipment, invest in its maintenance and in applicator training so you can get the best results from every single spray that you make. So to wrap up, we have limited control options for Botrytis and few rescue products, aka synthetic chemistry. So even in conventionally grown crops. So add that to the list of growing fungicides in different frac groups, that Botrytis is going to be resistant to a lot of different synthetic fungicides. And that makes it imperative that sanitation and cultural strategies form that foundation for your Botrytis control. Implementing those to reduce Botrytis ingress and incidence and creating conditions that favor healthy plant growth and produce a robust crop. And that really should be your first line of defense, because those plants are going to be inherently more resistant to infection. And these activities then create conditions where disease pressures are lower, and it sets us up for the use of biofungicides for success. And with that, hopefully you're still awake. I'll wrap up and say thank you very much for listening. I believe we can take some questions, Robin, now. Yes?
Yes, we can.
Super.
And we have gotten quite a few. We have great attendance
Fantastic
today and a lot of questions. So we'll get through as many as we can. And if we can't get through to your question, Michael will be able to follow up with you after the webinar, because we'll have your email and your question. So
Okay.
we'll do as many as we can. So the first one here is, can Botrytis spores be spread through things like rainfall in an infected patch? Or I could add overhead irrigation, things like that.
Absolutely. That's one of the points I was trying to make earlier. Overhead irrigation, if you have botrytis, if you think about it, large droplets from overhead irrigation, well, let me back up. Overhead irrigation typically means large droplets. When they hit a plant, they don't hit the plant, spread and run off. They hit the plant and bounce. And you get what you call rain splash. And that rain splash can carry anything and everything as it splashes. So you can get movement, not miles, but maybe you can get movement to adjacent plants from a heavily infected botrytis patch, for sure. It happens. If they're very fine droplets, yes, they can get carried further in wind currents, outdoors typically, but also within the greenhouse. So you have to be careful about how we water plants. And it also speaks to watering plants at certain times of the day, so that foliage has time to dry out in between waterings.
Right. Okay. All right. We just more recently talked about the biocompatibility. We have someone who wants to know, well, they said, you mentioned lack of compatibility testing causing issues with biofungicide efficacy. So where can I find relevant biofungicide compatibility data?
If you look, and I can speak to this from certainly BioWorks has an amazing compatibility data set that's available online. We have a biocompatibility tool, so you can actually go in, type in the BioWorks. This is obviously specifically for BioWorks products. You type in the BioWorks product, you type in your chemistry of interest, and it'll tell you, if we've tested it, whether the two are compatible. Now, those data are for tank mix compatibility. If they're not tank mix compatible, it doesn't mean you can't use the two products together. It just means maybe you have to wait a day, 2 days, 3 days, 4 days in between applications. So it's available on the BioWorks website. I know Lalamand too has really good compatibility data available on their website. And on some of the, for want of a better word, the biocontrol companies like Coppet, BioBest, etc., they have what they call side effects guides on their website. So if you're using natural enemies, predators, parasitoids, it will tell you which of those can be used together with certain products, including biofungicides, excuse me, and bioinsecticides. So there's a lot of resources available online if you look around, but try the biocontrol companies first. That to me would be the most obvious place to look.
Okay. All right, this next one makes me chuckle a little bit. How do I convince my supervisor to let me incorporate biofungicides when they appear to be more expensive than conventional alternatives?
Good question. Gold star to whoever asked that one. I think you've got to look at it from multiple perspectives. If we're talking in general biological strategies, sometimes this is more applicable for root diseases, but they only have to be applied sort of every so many weeks rather than every week or every 2 weeks. So you get a greater longevity out of that biological strategy. So it's not just, it's not enough to sort of compare cost to cost oftentimes. And I would argue that the cost of biological products compared to new chemistry, I'm not talking old chemistry, but new chemistry, they're pretty much in the same ballpark, whichever one you're using. Why you should convince your supervisor, what are the advantages of using a biological product? I'm not saying you have to use that biological product as a standalone. Best used anyway within a program, which can include chemistry. But the point here is that you can introduce biology to delay resistance. We don't have new chemistries appearing every other week. So it's imperative that we maintain the lifetime of the active materials that we do have. And that's where biologicals can help. The REIs, the PHIs associated with biological products are also much shorter. So there's a lot of other advantages that these biologicals can bring into a program. And as I kind of alluded to earlier, they are compatible with a lot of other biological products, predators, parasitoids. So if you're using those in a spray program, I would guess, it's a better way to put it, that if we're using a fungicide, do we think straight off the bat that might have insecticidal activity? Probably not. And yet a lot of, certainly again, older fungicides are basically contain the same molecules that insecticides do. So a lot of older fungicides have insecticidal activity too. So are you going to spray something that kills everything you've invested in to initiate a bioprogram? So I think there's a lot of obvious and clear and really great advantages to using biological products. Just considering cost is not a comparison. We also want to look at, as I said, the REI is important. You're creating an environment that's more user-friendly. You're creating an environment that's more worker-friendly. And let's face it, in horticulture today, one of the biggest challenges we face is attracting good labor. How can you create a better work environment? How can you create a better environment where we're not asking people to spray toxic materials? We're not asking people to work in plants that have been sprayed with toxic materials. And I think that truly this is an advantage of using biological products. So your equation X plus Y or side-by-side comparison just on cost I don't really think stands up. It's what value does the biological bring into that program? And I think there are so many that just looking at it from a cost comparison perspective doesn't really do full justice to the value that biologicals bring into a program.
Okay, that's a very thorough answer. Thank you.
Welcome.
Okay, and I have a couple questions here that are very similar. So I'll read the one. It's known that the dispersion of powdery mildew spores occurs mainly during the day in low humidity. If we reduce the humidity in the greenhouse against botrytis, can this increase the risk of powdery mildew infections?
Boy, that's a good question. This is all about balancing act, isn't it? I think for powdery mildew to infect, it requires high humidity. It's spore dispersal. I think it sort of gets to the point of it's excuse me, I'm thinking a little bit about this one, how I can phrase it best, but to just focus on one disease is probably not the best thing to do. It really requires looking at your whole plant production program, taking that holistic view of your production and your pest and disease management inputs. To use as a couple of examples, for something, potassium bicarbonate, let's pick on potassium bicarbonate. Potassium bicarbonate works against powdery mildew and botrytis. You could use that preventatively and keep both in check, but I think it still comes back. What's the best environment to reduce the incidence and spread of those diseases? I understand it's never going to be just do this and everything's going to be fixed, but I think you have to find that right sweet spot as much as possible to reduce both diseases in whatever way, shape, or form you can, and then to create an environment that doesn't stress the plant. Plant health is the most important thing. If we can do more to reduce disease incidence, to reduce spore formation and dispersal, even better. So I think there's a medium that can be found, but it's navigation. And I'm not going to tell people how to do that because everybody's crops, everybody's growing conditions are different. We can think about tools and approaches that can help us overall, but we must take that 10,000 foot view of your crop and then hone in and figure out which strategies can I use to take care of both diseases. And I apologize, there's no simple answer to that question, but it's the best one I got.
Okay, this is an interesting question. This listener is currently pursuing a PhD in plant pathology, And they say, given the focus on sustainable agriculture in my studies, I'm curious to know if there are any consumer concerns regarding the safety and potential health impacts of using biocontrol agents in greenhouse environments, specifically for microgreen cultivation.
Yeah, good question. There are strict regulations that we have to satisfy in order to get a product registered through the EPA, or in Canada through the PMRA. And part of that registration process involves doing toxicity testing to demonstrate that there are no adverse side effects that will result from use of these products. If you were to ask a consumer, I sense that many consumers have no idea how their food is produced, period. But there's a big consumer pushback against synthetic chemistry, that we do know. But I think a lot of synthetic chemistries have been clearly sort of documented as having measurable health impacts, whereas the biologicals, not so. Are they a concern? Should we be concerned? Of course, but that's why we have, like I said, guidelines provided by the regulatory authorities. I think it also speaks to why we need to be careful about what we use in plant protection. I don't want to get on a soapbox, but there are a lot of materials which are not registered and therefore not regulated, and these are used in some cases. Buying a registered product says this product is safe to use, you know it's consistent to use, and it has proven efficacy. That's a three-part guarantee. If I just buy on Amazon, Etsy, or you name it, you can buy products from anywhere. There is no written guarantee or anything about them at all. Mm-hmm. So there's again, I apologize for the long answer on this one, but I think it's important to consider plant protection. Yes. Should we be concerned? Yes. Should we fear them? No, because of the regulations that are in place. Consider what are the alternatives. And I think when you look at the alternatives, then biological control, use of microbial control is absolutely, the safest way forward for us to maintain, to be sustainable, to maintain productivity in our crops, and to ensure that we have a great environment that we can live in with all of the rest of the creatures and plants that live on this great planet of ours without impacting them negatively.
All right. We've got a few more minutes to keep going. So our next question is, are there some sanitation products that work better than others for, they say, sterilizing botrytis, but basically eliminating botrytis?
Gosh, there are a slew. I'm thinking specifically peroxides, quaternary ammoniums, which are really for cleanup, let's say, after a crop. Some of these sanitation products, some of the peroxides are actually labeled for use on plants, but it all comes down. Peroxide can kill a plant or save a plant. It all depends on concentration. So, I've been very broad and generalistic, but there are some really great sanitation products out there that we can use. Clean up after a crop, before you plant the next crop. It's just ideal. Make sure all of that dead leaves and everything else are taken out of that cropping area.
Okay. All right. This person I feel for, and there may be others from Florida on this webinar. So while it's not botrytis specific, they're asking, what are your thoughts on ways to prepare the plants for the hurricane? We're watering them to make them heavier, and I sprayed a general fungicide. Is there anything else you suggest? And maybe we'll say for disease.
Yeah. Gosh, I my heart goes out to you. Stay safe, eh? Specifically, you've taken the precautions you need to. One of the things I might suggest, if you have time to do it, is also think about the plants after the hurricane. Overwatering is not great for a lot of soil-borne diseases, but I understand why you've done it. keep a close eye on those plants. I think treating the plants with some sort of biostimulant after the hurricane's gone will help them recover. But before the next irrigation event, make sure that the media's not dry, but dried out before you next water. So I think it's going to be important to monitor the status of that growing medium, whatever it is. Using a biostimulant, the protein hydrolysates in particular are really great for helping plants recover from stress, to tolerate stress. So I suspect it would be a good material to use. So yeah, there's no, again, I'm sorry, there's no magic solution. I think you've done what you can do.
Okay. All right. Now you had mentioned fine mist. So when you say fine mist, how many microns?
Good question. 100 microns or smaller, I would say.
Okay.
Ideally. Yeah.
All right. Good. Boy, they're coming in. Are bacillus drenches effective when treating botrytis? And if so, which species are the best?
Yeah. Some bacillus species can induce plant defense mechanisms for sure. So if you use it as a drench, they can activate the plant's defenses. So they will have an impact on botrytis. Okay. There are bacillus species, it's Bacillus mycoides, Lifeguard. It's a Certis product. That actually is unlike some of the bacillus products we use as biofungicides, which have contact activity, in that they work, their sole mode of action is by eliciting the plant's defense mechanisms. So they enhance the plant's ability to defend itself. As for the other bacillus products, for botrytis, I would probably use them as foliar treatments, preventative treatments, just because of the metabolites contained in those preparations, the lipopeptides. They will really, on contact, destroy a lot of disease organisms on foliage, and they're very, very useful products, again, to insert in a rotation or use as a tank mix product. So you have options in terms of use of Bacillus or Streptomyces products, and they will be good additions to any IPM program. Okay.
All right, good. I'm trying to ask the questions that are having multiple people, so it shows there's a real interest here. Several people are asking about what kind of calcium sprays, or how you use spray programs using calcium preventatively. So if you could just talk about calcium a bit and botrytis.
I'm not the person to ask, but I'll give you my limited knowledge, and that's what it is. So please take this as it's given. Calcium chloride typically used to spray plants, and this is common in poinsettias this time of year when they're going into bract production, for example, because it's the way to get calcium into the plant and to those leaf margins, into the bracts, so that you don't get the necrotic tissue developing. What I mentioned was use of, and by product, it's a BioWorks product there. I've said it, it's On Guard. And we do have a recipe. We used to have a product called On Guard Calcium, which was a combination of calcium plus On Guard. But we still have On Guard. It is a really efficient way to get calcium into the plant. It enhances movement of calcium into the plant. So you can typically say cut your, if you're making calcium sprays, say you're using 400 parts per million, I'm just making this up, you could probably cut that down to 200 parts per million if you use it together with On Guard, and you'll see higher levels of calcium accumulation in the plant. It's that good a vehicle. It kind of forms a cage around the calcium molecules and shuttles them into the plant. So entry into the plant is much more efficient than using just a calcium spray alone. So there are ways to get, calcium is, and I'm sure, talk to your reps, they'll have a range of different calcium products that can be used, but certainly we know by combining calcium together with a protein hydrolysate product like On Guard, uptake efficiency is significantly improved, and that benefits the plant.
All right. Well, thank you, Michael. I think we're going to need to wrap up. There are a number of questions we didn't get to, but like I said, we have your email and your question, and you'll receive a follow-up a little bit later. So we want to try to address everybody's concerns. Yeah. So we're going to go ahead and wrap it up. And as a reminder, an on-demand version of this webinar will be available within a couple of hours of now. It just needs to render, and you can use the same link that you used to register today. And you will also receive an email tomorrow that will also have the link. So if you want to go back and rewatch part of it or check on some facts, you're able to do that. And it will be up for at least 6 months of recording. So I want to thank everyone for joining us today. And of course, thank you to BioWorks and to Michael Brownbridge. So have a great day, everyone. And yeah, great information, Michael. Thank you.
Thanks, Robin. Thanks very much for hosting. Thanks, everybody, for being here.